Enjoy the webinar, everyone.
Good morning, everyone. My name is Mike Reed. I'm here to talk you through building hopefully not your first cube, but walk you through building an analysis services cube, point out some of the best practices, maybe some performance tips. There's a couple of utilities I'd like to talk about, Biz Helper and OLAP pivot table extensions. So let's get started. First, can we confirm, somebody confirm you can see my screen?
Yep, you're good to go.
Type in the chat window if you would, please. Okay, all right, thanks. So building a cube, where do we start? Obviously, we need data from somewhere, so we'll start with something that looks like a data warehouse. Hopefully it's in, by the way, I'm referencing analysis, the AdventureWorks 2012 data warehouse for all of the exercises here. It's conveniently built into dimension fact structure, dimensions containing all of the usually qualitative attributes, the facts containing the quantitative, as in counts and quantities and etc. So starting with the data warehouse, if you don't happen to have one, you could more or less fake it. Certainly for experimenting purposes. First thing I wanted to talk about anyway was the use of views as an abstraction layer between your data warehouse or your data source and your cube. A number of reasons for this. It gives you the ability to transform your data, match it up to the internal analysis services types. It allows you to create calculations that can be done out of your database. Obviously, if you need an average of something, you're probably not going to want to do that in a view. You'll save that for the cube since it would become member sensitive in the cube. There's you have the option of using query hints, locking hints, join hints. It gives you the chance to take what is normally not a human readable database structure or database naming convention and turn it into something that is very human readable. Noting that analysis services, when you move when you add a table to your DSV, create a dimension out of it, it will it's looking for a camel case structure, so it will provide a word break at every capital letter, so it helps make things a little bit neater and a little nicer looking. Again, the views allow you to alias, so if you have different business units that one may be marketing and one may be production unit, and they use different terminology, a view would let you display the same data in their group-specific terminology. So views are easy to create. If you do something very similar to this, you can go select all of these. And you have a view. Run that and, oops, you should not leave this in here. And you have a view, so they're very easy to create. And again, they provide a nice abstraction layer. You come through and for some reason somebody, this always seems to happen. We swear it never does, but it always does happen. Somebody needs to rename a column or actually change a table out. You may be migrating from one data warehouse to another. As long as the name of the view and the columns in it stay the same, you're golden as far as the cube goes. It doesn't care. Well, the data types have to be the same, but you can swap those out underneath the cube, and it makes it really easy. So views in your cube, great way to go. I don't see it done often enough. We talk about it a lot here. It's kind of crazy how many places we go, and we wind up in a situation where we really wish we had had something there that would save us from pulling a new dimension into our cube, or hitting that refresh button on the data source view panel and having a bunch of columns update, and then all of a sudden you have, pull this up real quick. All of a sudden in your data source view, you have a number of columns that would be dropped or changed, whatever. And of course, as soon as you hit OK, which you have to do, then it starts blowing out all your relationships in here, if they don't happen to be carried through if they don't happen to match. So, starting with your data warehouse, again, we're looking for a fact dimension relationship. So, how familiar is everybody with the data warehouse structure, fact dimensions, etc.? Has anybody read the book on the data warehouse toolbox? Lots of good reading, easy enough. So dimensions typically, most cubes actually all, well, you don't have to have a date dimension, but most of them have some sort of date something to them. So date dimension, you'll have a number of data attributes. Typically wind up in a hierarchy where you'll say, a year is a parent of a quarter, is a parent of a month, is a parent of a week or day, etc. You may have product, in this case, product groupings that may be intrinsic to the product dimension. You could be a separate dimension as they are here, product category, where ultimately you'll build hierarchies out of these. So that says those are essentially groupings, parent to child, that you can either allow you to either select the entire hierarchy or parts of the hierarchy and pull those into your result set. Facts, on the other hand, should look, we're going to work with internet sales. So facts should look like this. They really should have nothing in it other than a series of keys. All of your dimensions will have a key, which should be your primary key, and those keys are referenced in your fact as a series of keys. And beyond that, you'll have all of your integers, your dollar amounts. Here we have tracking numbers, attributes of. This relates to a specific transaction. So, or a recorded event. So we have at this event recorded quantities, freights, tax amounts, etc. Basic fact structure. So with that said, if we had views, which we really don't in this cube, actually I'm not going to use them in the I don't want to blow my AdventureWorks project up, but as an example, simple enough to create. In here, I added a couple of, this is where views come in really handy, so I added some groupings. Okay, so we have a customer, we have a yearly income for them, and I want to put them in some sort of bucket that I want to expose in the cube. This is where this comes in really handy for two reasons. One, you can do this here, and you can do it in SQL Server where it's really good at it. And B, as long as these stay the same, if I decide, well, the analysis I'm doing says that my breakpoint should really be at 15,000, 40,000, and 80,000, I can change the view and deploy a single view, reprocess the cube, and I'm done. I don't have to do anything in the cube other than reprocess it, no deployment, etc. Getting cubes deployed is considerably more difficult in most IT departments than getting a view deployed or even an alter statement to an existing cube or to an existing view, sorry. So I did nothing special in this one. Let's go to internet sales. So here again, I've done some basic calculations in here. So you have a number of options where you can put calculations like this. You could do them in the database itself, as a computed column. You could do them in the views. Obviously, if you do a computed column, then you're going to be doing alters to your tables. If you do them in a view, again, very simple to change. If you think it needs to be something else, you can do them once you have the cube built. Actually, one more layer. You can create a named query in your cube, and you can do calculations there. And then you have measure expressions, and we'll go through all of this, or you can also do calculations, and then you have the actual calculations. So there's a variety of places where you can put this sort of business logic, which brings up a really important point. So where do you want your business logic? Do you want it in your database? Do you want it, and do you want it in the data layer itself? Do you want it as, exposed as part of views or procedures? If you don't do it here, then where are you going to do it? And as you move from here, then you move obviously into your cube. And is that going to be visible? Are people going to be able to find it? Is it going to be easy to maintain? Rule of thumb, at least from what I recommend, is keep all your business logic out of your cube unless that's the only place it can go. If you have something that's specific to your cube and is unique and has nothing to do, it may have to do with a business group and how they decide to calculate something, then maybe that belongs in the cube. Certainly could be a different view specific to that business group. So views, good choice in my mind, very good choice in my mind. So let's pull up our project over here. To build a cube, I don't know how many of you got, well, most of you are beginner level. So building a cube always starts with the data source. So all of this would be blank except for, actually, let's just do this. I'll come back and reference this in a minute. Yes, there's okay. I'm going to leave all this where it is. I don't really care. I'm going to delete it after this. So Visual Studio, SQL Server data tools, if you will. So we need to get data. So where are we going to get it? Right-click, new data source. Where do we want to find it? In theory, you probably won't have any of those. So let's go. I'm going to save you a little grief, or a little pain, and just copy some. Server name, database, WHICHWORKS 2012. I'm using a copy of it. So we'll go here. We'll go finish, and we'll leave this. We'll take that off. Now I blew right past something. So this cube is going to, or this data source is going to complain in here. Do yourself a favor from the very start. Set up an account or a login for your analysis services service account and give it access to the data it needs in your database. If you do that, then you'll save yourself a lot of grief later, because they'll come back and complain that, oh, you can't use that sort of credential. So while we're talking about this, there's a number of considerations in what you choose. Here I let it choose the default. Went to SQL Server native client. That may or may not be what you want to use. There's a lot written on potential performance improvements in using other providers. We can check that out a little bit if you want. So here we'll say we're looking at native client. Actually, I've got another project for this. So here we are using, again, the native client. So a couple things you'll see. You really have two options, or two things you can play with. One is the provider itself, and the other would be its packet size. 0 is the default. I'm going to leave it at that for a minute. So what we're wanting to do, the theory is that different providers will interact differently with your network and your database and the configuration of your database and everything that it has to go through. As far as remember that a provider doesn't just make a connection, it also does typecasting, it does translations of queries. Some of them may be iterative, and some of them may actually issue a set-based statement. So there's a huge difference in the providers. Everybody typically just goes to the default, and that may or may not be best. In fact, in our experience here at Pragmatic Works, it's quite frequent that the OLEDB provider will very often, this guy, OLEDB provider, will very often provide better performance. So check those two out. You can do that by, you need a, let me get this thing out of the way. You'll need a project to work with, obviously. And you'll need perfmon running. And you'll need an MDX query to clear your cache. Let me see if I can find it over here. Yep. Oh, we're not in the right spot. So down here, analysis services, databases, XML query. So it looks something like this. So for example, we are going to take my demo project here. We're going to deploy and populate the cube and process the cube, and we are going to watch it over here. So counters we're looking for really are just two. You go to MS OLAP. I'm using 2012, so the nomenclature is a little different. We want processing, and we're going to look at these two counters, rows read per second, rows written per second. I already have those selected over here. So as you can see, we're seeing nothing right this moment. So hopefully all this will work. That's the one I'm after. So let's come over here, and actually let's do this first. Okay, let's come over here and process this. sure. It's very small, doesn't take very long. Hopefully it'll run without failing. We should see something pop up over here. So rows written per second, looking at about 190,000. I'm sorry, I got that backwards. Rows written are over 600,000. Rows read around just under 200,000. So actually quite fast. I have a total of 2 million rows in this, in fact, internet sales that I pushed in there yesterday, prep for this. So it loads quite quickly. So let's close this. We come back here. Let's pick a worst case scenario and do something really silly, like say I want a SQL client data provider or .NET provider, which should be really horrible. Oops, this guy. Okay, let's clear cache again. Come back here. Deploy and process. If anybody has any questions anytime, please just type them into the chat window. If I'm going too fast, I'm not explaining something well enough.
Hey, Mike, we are having a couple of people say that it's a little bit blurry and the font is small. I don't know if there's any way you can fix that.
Okay. Let me see what I can do. See, I don't know if I have Zoom it installed on here. Give me just a minute. I'll change the resolution on that monitor, see if I can kick it up. Oh, that's a bad format. Does that help at all?
Yeah, that does look a little bit better. And everyone, you do have a Zoom option to the top left of the GoToWebinar viewer if you're also having trouble.
Okay, so let's come back here. Let's run this back over here and see what we've got. So here it looks like we're showing a max of 30,000, which is kind of what we expected. So .NET, we know those providers typically are iterative, a row at a time. So again, that's just an example. I would rarely suggest using that, only when you have to for some of the, you'll see it more in analysis and integration services. Some of the tasks require .NET connectors. That's the best place for those. I'll stop there. I think we're going to run out of time if I don't keep moving. So look at the, again, data provider, and here in the All tab, your packet size. Obviously, well, not obviously, you can't change that to exceed what's configured in your SQL Server. It won't complain. It'll actually just change itself back. But packet size could be almost anything. I've actually found cases. Most people say, well, the bigger packet is a better deal. 32K, if you can. I've actually just this morning when I was playing around with this, I had a case where a 4K packet actually worked out fastest, which is kind of interesting. So it's so much dependent on your particular environment, your network, how your data is getting from your storage devices to your server, and then obviously to wherever the cube is hosted. Close a couple things over here. Be right with you. So we covered views. Let's go on, get this project out of here. I don't think we need it. And let's go to this one. So created a data source. I'm going to leave it where it is. The next thing we need to do is we need to create, this is another layer within the cube, is we need to create a data source, which allows you to bring in your tables, your dimensions, define relationships, and you can have multiple data sources, data source views rather. So you can, if you have multiple cubes in this project, you can certainly build a data source view specifically for those. So here we're going to, wait a minute. Let's go, yep, let's do this. What? It's giving me a hard time this morning, so here we go. So next, okay, clicked on the wrong one, sorry. So here in your data source view wizard, you have the option of bringing in tables, dimensions, everything you want. In our case, we're going to bring in, let's just go, let's say we want customer, we need date, we need product, and let's just bring in one fact, internet sales. You have the option over here of adding related tables. If you click this button, it's going to bring in probably everything over here. Anything that's related, that has a relationship to fact internet sales, is going to be pulled in. And actually, I should probably do that. Otherwise, it's going to complain later about not finding keys. So we make our choices. If you had actually created views, you could select those from here. You have the option, you could type in VW here and or just V and filter, and it'll show you what you have. So it helps to make it a little easier if you have a very long list. So here we're going to call our data source view, VentureWorks 12, finish this up. Cool. Now we have a data source view. So it has gone out and read all of the relationships, looking at foreign keys, and built this nice star schema for you. So again, pretty good looking data warehouse. This is obviously what we like to see. Maybe in some cases, again, back to the views, there's a lot of stuff that a lot of columns, a lot of data we brought in that you may not want in this particular cube. Great place for a view. We'll leave it all out. So we have our data source view, now what? So now we have to create dimensions out of those. So there's a whole series of, we're going to use an existing table. Customer, might as well start there. It's already selected the key for us. Yes, so let's see, we have geography. I don't think we care about names. A couple of attributes. I don't care about whatever. Let's talk about income. That should be enough. Okay, Jim customer, call that good. So I don't know if you want me to torture you with all of this and go through and building all of these. Let me pull in one that's going to be a little worse. Oops. Sorry. Dim date. Those are always fun because they have day number of month, English month name, month of year, calendar quarter, calendar year. Let's just go with that. Simple date dimension. So dates are always kind of fun. This is an example where you would absolutely want to build a hierarchy to say this is how these relate to each other. Because if you look at it now, they are all related directly to the date key. It doesn't understand that a month is part of a year and a quarter is part of a year, etc. So we'll build a hierarchy real quick. Drag and drop again. Thank you, Microsoft. They make this all quite easy. So we'll bring over month number and we'll bring over day of month. Truly, I didn't need this, so I'm going to get rid of it. I'll show you why here in a minute. So we'll call this calendar year. It's not going to like that. So it needs to know how all these relate. So we're going to take the day number a month, drop that into the month. We're going to take the month number and drop into our quarter, and our quarter into our year, and now we've told it days are part of a month is part of a quarter, etc. So it should be very happy. In this case, best practice would say these should all be rigid relationships, and you'll get some warnings about that. I'm not going to take time to do that, but that's really all it takes to build a hierarchy. We can now, once our cube is built, we'll have a calendar year hierarchy. We can drag that in. This gives us ability to drill down. Analysis services knows how to build aggregations based on this, so days roll up to months to quarters to year, etc. That's what all of this is about. So I'm going to leave this project and go back to the AdventureWorks project. I don't really want to torture you with everything. So data source view, obviously more complicated here. It looks impressive, but don't be put off by it. Let's go for our cube itself, and here we have our cube structure. So we started creating dimensions. Once you create dimensions, then you have to actually come over here and add dimensions to your cube. So here you would select from the list if it's not already here, and it will add that to the cube. Once you actually build the cube, it goes through the process of, it'll read all the measures and will build all of the measure groups. So a measure group is essentially a fact table displayed as a measure. So we talked about internet sales. You saw what was in it. It created a measure group called internet sales with members or measures named by the column names. If just as a note, if these were duplicated, if you didn't have the internet on here, sales order quantity, if those were duplicated, it would have gone through and added internet sales dot blah blah blah. And here it gets kind of long and ugly. So you might think about naming your measures uniquely so you don't wind up with this giant name and having to go in and your properties and give it a different name. So we talked about different places that, let me go back for just a second, talked about different places that you can do calculations. You can, in here, this one happens to be, I'm surprised, happens to be a named query. Let me find one that's not. Okay, so you don't see edit name query in here. That says that you're looking directly at a table or view. You can confirm that by coming here and seeing that you're actually looking at DBODIM date and it's a table. If, perchance, you decided you needed to do something on the way in, you can create a table from a named query. So here we have our SQL and another place, like I said, where you can bury more business logic. Really highly recommend against doing this. There's kind of no point in doing this unless you've made a business-wide decision to put all of your business logic in your cube so it all travels together. Maybe that's the, that may have already been set in stone and you can't change it. If you can, I would highly recommend not doing this and putting that information in a query in a view and leaving this as simple as possible. Something to note about SQL Server, whether it's analysis services or the SQL Server database engine, it likes simple. The more simple you can make things for it, the better. The way you write your queries, if the more simple they are, the more basic they are. If we're having 48 joins and 13 subqueries is ugly. It's hard for the query engine to parse that out into something it can actually build a good plan on. Same thing applies here. Anything you can do in the database should be done over in the database. Once you pull it in here, try to keep it as simple as possible. Keep it clean. Do things in here that you have to do. Which would be where you want to reference an aggregation. You want an average of or a prior period order quantity, for a month or a year or whatever, where it's rolled up. Obviously, you can't do that easily over in SQL Server. It's not built for it. So it has to do it here. So leave it here, but put everything else elsewhere if you can. So we created a number of dimensions. Once the dimensions were created, at that point there would be nothing here. Just right-click, tell it New Cube, and the wizard will walk you through what you want to use. Use existing tables, blah, blah, blah. And in the space of a couple of minutes, you'll have a cube, and it will very much look like this. Probably not this complicated, but you'll have measures, measure groups with measures in them. You'll have dimensions. Note that in our fact, we have a ship date and a delivery date, and our date dimension is what's called a role-playing dimension. It has the date dimension itself only has one date key in it, but the fact sales table has, let me go back here real quick. Has multiple date values or date keys, so order date, due date, ship date. When you build the cube, it will automatically build a new dimension for each of these. So we wind up with a cube. What do we do with it now? I mean, at this point, you don't have to do much more other than you should confirm your dimension usage. This one's really kind of ugly, but what this amounts to, this is how analysis services knows what's related to what and how it's related to what. We're looking at internet sales as our measure group. They don't really care about these others, so it's saying that there's a relationship to date dimension on the order date key. Here we have, so you need to, this would be a good place to remember that we have a date dimension down here. Based on that relationship, that's actually order date, and this should be renamed. So we have an order date, we have a ship date, delivery date, all of them on their appropriate keys, customer. I don't know that we have any one-to-manys in here. Yes, we do. No, let's don't talk about that. That's not really a beginner level discussion. So if you have a dimension in here that does not have a relationship to the measure group, the behavior you can expect to see when you go to browse your cube is that when you pull in a date, nothing changes. Whatever you had, if you had let's pull in order quantity. If we were to pull in let's go calendar year. If we pull in our year, what you would see is that same total of all of these displayed for every one of these. That's a clear hint that you have a problem with your dimension usage where you do not have a relationship there. So easy way to figure out what's going on. So you can see what we have here. We have some really basic dates. We have year, month, quarter, whatever. But what's typically, it's always missing actually when you first build these out, is any sort of time intelligence. So you can come in here and you can add time intelligence using the time intelligence wizard. The issue with that is that if you go in and select say I want, it's going to say pick a dimension and pick a hierarchy within the dimension. So you're going to have to apply time intelligence to each of these if you want a prior period, last period, etc. There's a really easy way to deal with this. Takes a tiny bit of work, but it looks kind of like this. So we'll come back here. I don't think I have. Yes, I do. I didn't really want that there. Let me check something real quick just to make sure I know where I'm pointed. TNT, okay. So in this database, I've already done a little bit of work. So what we can do is create a new dimension. In this case, we're going to call it date calculations. This would be called dynamic time calculation. So we're going to grab a little bit of code that I have tucked away over on the side here. And first thing, create a table. Looks like this, which I've already done here. Oops. We are going to add a few rows to it. Looks like this. So we're going to insert 4 different calculations: actuals, date, year to date. These could literally be anything you want, whether it's named whatever you want. So, highly modifiable. What we wind up with in this dimension is 4 rows. Looks like this. So with that done, we're going to come back over here. In theory, we would also build a view on top of this and go through that process. Let's come back to our data source view. I don't see it here. I thought I removed it. So yes, we're going to, in our data source view, we're going to add a table. We're going to grab date calculation, to add that. Let's just put it up here by date. So this is a little unique in that it doesn't actually need a relationship to anything. So we'll leave it here by itself. We will add a dimension, existing table. Next, let's grab our, should be the last, always adds them at the bottom. Doesn't know what the key is, there's no primary key created on it. So we need this, we don't need to, fine, we'll hide that in a minute. So we'll call the dimension date calculations, and now we just added our date calculation to our dimensions. We need to go back, there's no hierarchies or attribute relationships, anything else we're going to create here. We do need to go back to our cube. And we need to, wow, let's dock this again. Thank you. And we need to add this to our cube. The calculations, okay. Dimension usage, it should show up in here. With no relations. Not an issue here. We're going to deal with this in our MDX. So we've now added a dimension that really does nothing other than provide some placeholders. Now we get into our MDX. So MDX looks kind of ugly sometimes. It kind of is sometimes. Sorry about that, but that's kind of the way it goes. If you want some good examples, this AdventureWorks cube has all sorts of interesting stuff in it. I'm a database developer. I really prefer to look at all of this in script view. I don't really need the rest of this. So something to note, calculate has to be here. And usually should be first unless you're doing something with the modification of leaf nodes. Calculate should always be first. If you take that out, your cube will not calculate. MDX is executed in order in here. So if you create here we're creating a member of the current cube, something called Internet Gross Profit. You can reference Internet Gross Profit anywhere after that statement. So we're going to, for the sake of keeping this kind of pretty, I'm going to do this up here. So I'm going to create a new section. And here we'll start putting our statements in. So scope statement creates a subcube, is what it amounts to. It says for within this space, calendar year to date, within our calculation, anytime you reference that, it's going to assign this value. It's going to aggregate year to date, calendar, current member, whatever that current member happens to be, and whatever attribute or hierarchy level you happen to be at in your date dimension, and is going to multiply it by the actuals. Actually, sorry, it's not multiplying. It's just going to assign the actuals value to it. So a couple more that align with the with those rows that we inserted in our new dimension, calendar previous period. Scope. Here's our calendar, our diff, previous period. I'm hoping that this will build. So let's see if it does. Looks like that part's good. For anyone interested, by the way, I typically don't really like it to automatically just process everything. If I make a change, I may want to deploy it, see if it actually builds without letting it trigger a processing cycle. So I'll show you that here in just a second. Actually, I'll show you that in this other project. So in your project, you have properties. And within the properties, you can tell it what to do when you deploy it. So processing option here, default, this project would automatically process the cube every time you made a deployment. And like I said, I typically don't like that. I can click it myself. So and depending on what you're doing, if your changes are extensive, you may want to go to deploy all. Your local host. I have found that to be issues in some cases, depending on if anyone's familiar with your host file. If you don't have a listing for your own machine in there, it may not resolve and it may take quite some time. Highly recommend putting your actual server name in there. Consider that a best practice and a tip that I've seen work in a lot of places. Oh, great. Well, fine. Scoop, scoop, scoop. Okay, quick troubleshooting deal here. So, problem here is we can't see anything at this point. If you try to, the beauty of working in here is that you can drag and drop these dimension attributes over. And in this case, we can't. So the only thing we can really do is take this out, reprocess the cube. So we'll reprocess the cube, and once that's done, we can paste that that MDX back in, and then we can check we can actually drag and drop the measure names, attribute names over, as opposed to pasting them in. Apparently, I've got an issue with it. This is always the painful part. It's great to work in small cubes. Another good place for a view, a good use for a view. If you're working with a fact that has a jillion rows in it, with the view in there, you can select that down to some number of rows per time period, some smaller set that would allow you to not spend all your day sitting and waiting for a cube to process. Just shorten your fact up. You probably don't want to. What? My level fiscal. Why is this complaining? Well, this is a little bit of a problem here. I don't have time to really work this out, and I had been through it this morning, but it seems to be wanting to give me a hard time now. So why is it saying we don't have fiscal? Well, I can't show you with the other one. I'm not going to make it through this in time. We are so close to out of time. I guess I'll try to explain what it's trying to do. So with our MDX here, what this is doing is just giving it the cube a value, is telling it how to calculate the value for these attribute members. So calendar, previous period, etc. Bottom line is, if we were to look at this actually browsing the cube, or look at this, connect to it via Excel, you would see that you could drag our date calculation dimension into the browser. This isn't going to browse either because it's dead. Drag the date calculation dimension in, drop that on columns, and I don't think I have, nope, I had a sheet open earlier. And you would have all of our new date calculations available on your column. So it would show prior period, difference in prior period, actuals is the current period, etc. So it gives you a way of creating a simple table. Like I said, pretty much a placeholder over here, coming to your cube, adding it in as a dimension, and then assigning values to that through your MDX, and then being able to use those and use them with any of the other dimensions, which is not how it would work if you use the built-in, inbuilt time intelligence wizard. So we're almost out of time. Do we have questions?
Yeah, there is a couple. You ready for them?
Sure.
Okay. Can you recommend a good book for learning how to develop cubes?
Sure. The Data Warehouse Toolkit. That's kind of the Bible. There is one specific to Microsoft. I believe it's called the Microsoft Data Warehouse Toolkit. It's a Kimball book, which most of the planet subscribes to as far as the methodology and such. But that's really a great place to start. Go to Ralph Kimball's. Just Google him. He has an awesome website. Posts a lot of material out there. Lots of tips and tricks and blogs and training information. Again, it's an invaluable resource. He very much is an authority on cubes and cube structures, and he's stayed up to date. He just published some new white papers here in the last couple of weeks that I saw come across my email.
Could you pull back up what the data calculations view looked like in SQL?
The data calculations view in SQL, the DSV, or the table?
Was not
this
stated.
Guy?
Was not stated.
Somebody wanting to, whoever asked that question, could you be a little more specific as to what you're trying to see?
We'll go ahead to the next question while we're waiting. Currently, we are doing a full cube processing nightly. Is there any easy way to do incremental or just process updates on a nightly basis?
Sure. That's just I guess it depends on what you're actually doing. If you're, that's a setting in your cube processing. You can tell it to actually, if you leave it at its default settings, it will typically default to whatever's best for it. If it sees that your dimensions haven't changed or you've updated something in the dimension or added some new rows, it will process only what's changed. So it does that pretty much by itself if you leave it in default mode. In my case, I had told it to process full, and so it was doing that. But right here is where you would tell it what you want to do. Leave it at default and it'll figure it out. Full reprocesses everything. Data only does the data and not the indexes. Structure processes just the data relationships. Process clear will actually clear all the data out. I don't see process indexes in here, which is kind of interesting, but it should be there. So yes, leave it at process default, and or you can go into your measure groups, not your measures, but your fact partitions, and you can specify how those are processed on a partition by partition basis.
Okay.
We obviously didn't talk about partitions, but
Well, that's all the questions we have for today.
okay.
All right. Thanks, everyone.
Thank you very much. Have a great day.